not sure how this is going to come out. Have everybody's quiz? Okay, so the two problems that I just gave you were problems I took directly off of an exam that I gave a year ago. So these were two of the problems that came off that exam. There were two versions of the quiz, but they're very similar. So let's just look at this one first and see how this works. You don't read that? Okay. Hold on, let me figure out how to read this. Okay, so for this one, you don't read that? Yeah, we do. I know this thing has a focus on it. That's the right half of it. Good enough? Yeah. Okay. So, trig sub, because you've got square root of x squared minus a squared. A here is 3. So the appropriate trig sub is x is equal to 3 secant theta. The derivative of that is 3 secant theta tangent theta. The square root turns into 3 tangent theta. When you substitute everything in, can't forget about it, you should be left with 1 over secant squared. 1 over secant squared is cosine squared. And then you do power reducing. And then you have to change that cosine 2 theta over to 1/2 sine 2 theta. We did that, we've done it so many times now. And then once you get to that, take the antiderivative. Once you get to that part right here, you have to solve for theta. So you go back up here, you do arc sine or arc secant, inverse secant on both sides. And then you need the reference triangle to come up with sine and cosine of theta. There it is. So that's that one. The only difference between that one and the other version was that instead of x squared minus 9, it was x squared minus 16. So you had 4s in there instead of 3s. All right? Then, on the second one, there we go, that's better. Okay, so on the second one, all you had to do is complete the square on the bottom. So if you complete the square, you'll be left with, something like in this one, it was x plus 2 squared plus 9. And that looks a lot like 1 over u squared plus a squared. So that's formula 17, which is what we started class with last time. Once you're there, you're right to the formula. And the other version, I showed a little more work on the other version. The other version, same completing of the square, you get something a little different. Write it down. And I actually made a little u substitution here to show that it turns into 1 over like u squared plus a squared, and then just go right to the formula. Okay. So I think that quiz will give you some indication of where you are right now. Now the test is still a little ways off, right? So you've got time to adjust. But you'll see what I mean by you get a problem, you're just you're not 100% sure what you're supposed to do with it. Or was it obvious in this one? Was it obvious that was trig sub and completing the square?
Well, you left it as what sine plus what cosine?
Oh, yeah. I mean, it's algebraically correct, right? Yeah. Okay. Next order of business is to finish the problem that we were working on last time, which was we had started partial fractions. We spent the entire day just preparing ourselves for being able to implement partial fraction decomposition, right? So there were a set of steps, and In fact, I told you not to even worry about this section for homework, that to go back, review, trig sub, get yourself up to speed, right? That's what I said. So, back to this now. We had started this problem, and the first step was to compare the degree of the numerator and denominator, right? So the degree of the numerator is smaller than the denominator. In that case, we move on. We don't do long division. So now we factor the denominator, and I think that's where we had stopped. Verify yourself. We had stopped. We had factored the denominator. What is the denominator factor again?
X, quantity 2x minus 1, quantity times quantity x plus 2.
Okay. So that's where we were. We said, okay, this original integrand, the thing in there, can be factored that way, and now we're going to use partial fraction decomposition. So we identify that there are 3 distinct linear factors, right? These are all different, and they're all linear. So for each distinct linear factor, I will need to put so a constant over the first linear factor plus some constant over the second linear factor plus some constant over the last linear factor. And that method is what you did in pre-cal, hopefully, and that method is also what I talked about at kind of the middle end of the class last time. So are we all comfortable with that? Okay, now we have to go figure out what A, B, and C are. So what was the next step? It's trying to figure out what A, B, and C are. Multiply by the LCD, right? By the least common denominator. Now, I had not done that, right? No, I had not done that. So, if I multiply this entire side by that denominator, then the denominator is going to go away. And all you're going to have is a numerator. And that's going to happen every single time you do one of these problems. Okay, the left side is always going to wind up just being the numerator. And then the right side, I'll go ahead and put it in here. No, I'm not going to do it with that one. Put it in here, just maybe on this first one. We're multiplying this side by x times 2x minus 1 times x plus 2, right? And that gets distributed here, and here, and here. So when I hit that first term, a over x, with this x and the x in the denominator cancel, right? But you still have these 2 terms, or these 2 factors, and you have the a. So I'm going to have a times 2x minus 1 times x plus 2, right, plus Russell. All right. Still trying to recover? Russell, what's my second term when I distribute here to here? So what cancels?
I do look at.
Luis? Here to here, what would we be left with?
So we're you're canceling the stuff on the bottom, right?
Something will cancel. What cancels? When I do multiply this times it.
2x minus 1.
Okay, so what's still there?
C.
I'm sorry? Did you say D or B? Did you say B?
B.
B? So the B is still there?
X plus 2.
X times x plus 2. Right? Do I need to show this? Okay. Plus, okay, what happens on the next one?
X plus
You just lose the x plus 2, right? So you have cx and then 2x minus 1. All right, so that is multiplying through by the LCD. Okay, now, once we get to this step, there are 2 methods, short and long, right? Short one is where you just try and like manipulate things. You let x be something. So let's try the short way. Okay, so let's say we're going to try and figure out what a is, all right? What we need to do is pick an x. We get to choose it. So that this thing is preserved, but the b and the c terms go away. Yes?
Let x equals 0.
X 0. Y'all agree? If x is 0, it'll kill this. X 0 will kill this. but x being 0 here will not kill this off. So we do that. Let x be 0. Now, if I do that, I have to rewrite the entire line, okay? So I'm going to start at the left side. If I let x be 0 here, I get what? -1 must equal, okay, a times, all right, what do I get when I plug in 0 here? You get 0 minus 1 is -1, and then what do you get when you plug in 0 here? 2, and everything else is gone, right? Everything else is gone. So all you're left with here is -1 equals -2a, right? And that means that a is what? A half. Okay, so now we know what a is. Now let's see, can we get b using the same sort of approach? Can we somehow preserve this, but kill this and kill this at the same time? You should be able to.
Well, if you have a -2 in the A, you have 0. For x, you'll have a -2, you'll have a 0 times the quantity.
Yeah,
And then it's
okay,
the
so
same thing.
why don't you do this? If we want to preserve this, is there a factor in both of these that's not in this one? This factor, 2x minus 1 and 2x minus 1 is in both of those but not here, right?
Right.
So make 2x minus 1 0. So just let x be a half. Right? Right? That would work.
Okay. Didn't think of that.
It works though, right?
I suppose.
Well, it does, because if you put 1/2 for 2, that's technically 2 over 1 times 1/2, and those cancel and turn into 1, and 1 minus 1 is 0.
Yeah, I mean, we just did this with 0 though. Isn't that what we did before this? I mean, we were trying to keep this here, and then the suggestion was to let x be 0 because this factor of x is in both of these but not over here, right? So 0 killed these while not killing this.
I'm sorry, can you say it again, what you did to get let x be 1/2?
Set that to 0. All right, now we have to plug in, right? And we have to plug it in everywhere. So what do we get when we plug in 1/2 here? 1/4 plus 1 minus 1, so 0, so equals. Now what do we know is going to happen here? It's gone. Okay, here it's not gone, right? That's going to be b times a half, because I'm replacing x with a half. And then what's a half plus 2? So those are 5.
3 halves?
3 halves?
3 halves.
5 halves. What is it? 5 over 2, okay. 5 halves, and then this is gone. Okay, so here's what we've got. We've got 1/4 equals 5/4 b. And then, yeah, divide or multiply by the reciprocal, however you want to do it. What's b? 1/5. Everything I'm doing right now is stuff that was pre-cal stuff. I know maybe it's been a while, but there's no calculus at this point, is there? Okay, last one. I need to let x be something. I want to preserve this one this time, so I get c. So I need to pick an x that's going to kill these two. -2. Okay? All right, so if x is -2, the left side becomes 4 minus 1, right? Square -2, 2 times -2. So that left side's going to be -1. This one is gone, this one is gone, and now I'm replacing -2's here. So c times -2. -2 times -2 is -4, and then -1, so -5. So that becomes -1 equals that, what is that, 10c?
Yep.
And that means that c is -110. So we know what a, b, and c are, right? All right, so now that we know this, we're ready to go after the integral. Yeah, I just erased the thing I'm going to need, but it's okay. You have it. So the original integral now can be rewritten. Instead of that integrand in there, it can be a over x, right? That's what we had written down, a over x. What was a for us? 1/2. So 1/2 over x. I'm going to write it this way, even though it looks weird. Okay, and then plus, and then it's supposed to be b over, what was it, b over 2x minus 1? You gotta make sure you get these in the right place. So 1/5 over 2x minus 1. And then finally, c, which is negative 1/10, over the last one, which was x plus 2. All right? So we looked at this very ugly thing. We used partial fraction decomposition to turn it into this. And the reason why that's nice is because now we can do those individually, one at a time, right? And they should be pretty straightforward, because I can do that plus, plus 1/5. Right? And each of these three integrals is a constant over a linear, and that's what we started class with last time. We said, can we handle constant over linear? And everyone was unanimous about that, right? So we have 1/2 antiderivative of this, ln of x, okay, plus 1/5. Okay, be careful with this one. Natural log of 2x minus 1 is a half in front. Good. So we have to account for that 2 in front. We have to scale that 2 out in the front. We did that last class. Look familiar? Okay, and then this last one, minus 1/10. Natural log x plus 2 plus c. And the only thing left to do is maybe clean that up.
Yeah, good question.
Yes.
Never mind.
Sure. Okay, just curious here. Could you? Could you do that? So what happened here? What did I do? Property of logs, right? Half goes up to here and becomes square root of x. This 1/10 goes up and becomes 1/10 power, which is the 10th root. This negative 1/10 goes, the positive 1/10 goes up and becomes 10th root. But back from college algebra, if you have the log plus another log, you can put them into one log with multiplication. So that became this. And then if you have subtraction, it becomes division. So this is, I condensed that log expression down into one final thing. I don't need it because these are going to be roots and they can't come out as negatives, right? Like none of this will ever be negatives. It's because they're even roots. Yeah. It wouldn't be wrong to put them on there. What's that?
Can we have the?
Yeah, this is okay. I just said, like if you look in the back of the book or something, you see that, you're like, what the hell? Okay.
I mean, I say that anyway because half the problems are, definite. That's okay.
Yeah, that's true. That's true. Okay, so that's our first partial fraction problem. We were able to do the shortcut there, right? And when we can do the shortcut, let's do the shortcut, all right? When we can do it, let's do it. I don't want to show that problem with the long way. Next on the agenda is this problem. Okay, long division, right off the bat. Right off the bat, long division. All right, so let me do my long division. I'm going to do it over here. Inside goes x to the 4th plus 0x cubed minus 2x squared plus 4x plus 1. So remember that 0 in there, right? And on the outside goes that divisor. And multiply x cubed by x, right, to get x to the 4th. So put x up here. I know sometimes you're taught to put the x above the x here or something. It doesn't matter. Put it anywhere up there. But down here you have to line things up. So x to the 4th minus x cubed, right? Minus x squared plus x. Then we come through and subtract. So subtract means it's going to change the signs of everything. That positive becomes negative, that negative becomes positive, that negative becomes positive, and that positive right there is going to become negative. And now we add straight down. These terms should cancel. These, just x cubed. Here, just minus x squared. And here, plus 3x, and then plus 1. And we play the game again, right? What do you multiply x cubed by to get x cubed? Or do we stop now? No, we can get x cubed to turn into x cubed. We multiply by 1. So plus 1, and then 1 times all those, right? Just don't forget to change the signs, right? Don't forget to change the signs.
We don't change the sign on the one
Where?
at the end. Plus
This
one.
last one?
At the end of down.
I haven't changed the signs yet.
Oh,
I'm about to.
oh.
Minus, plus, plus, and then that's a minus now.
Okay.
All right. Okay, now we add down. We got nothing. We got nothing again, and then we got 4x, and then 0. Okay, so 4x. Now we have to stop because we can't turn x cubed into 4x. So this is our remainder. So we always just tack onto this plus the remainder over the divisor. There we go. Oh yeah, that should be x squared, sorry. Okay, so we have done, again, this is just the long division part, right? Okay, so now what we'll do is I'm going to rewrite the integral. This integral now becomes the integral of x plus 1 plus 4x over x cubed minus x squared minus x plus 1, that whole thing, right? Now because there's addition and subtraction, or addition, because of that, we can just do these one by one, right? Like this one and this one and then this one. Now the first two, we can handle no problem, right? Yeah. It's that last one that we're going to have to do a little work on. So this now becomes 1/2 x squared plus x. So I took the antiderivative here, antiderivative here, and on the next one, I don't know the antiderivative yet. So I'm going to still work on that. And I'm not going to put plus c, because I'm going to get a plus c when I do this. So I'll just wait till the very end. Any questions on that? Now what? We've done the long division, we've got a new integral.
Can you factor the bottom?
Yeah, so now we're going to start doing the partial fractions. Now, we got to make sure, like, let's make sure this doesn't go another way. You know, like, maybe this is like a basic U sub or something like that, but it looks like we're going to have to do partial fractions.
Yeah, but you can't,
You can factor that by grouping, right?
Yeah, so if we're going to factor the denominator, we have 4 terms, we got to factor by grouping, right? So let me do a quick little factoring over there. We factor this, then I can do a factoring on the first 2 terms, x squared, left with x minus 1. And then over here we need it to be an x minus 1, so we pull negative 1 out, and we get x minus 1. And this leaves you with x minus 1 times x squared minus 1. Yeah? And then that's a difference of squares, isn't it?
Yep.
So this is like x minus 1 times x plus 1 times x minus 1, which means we have 2 of those, don't we? So this is really like x plus 1 times x minus 1 squared.
So where's the negative 1 and the x squared go?
Where?
When you brought it down?
Where?
From there?
He's talking about the difference of squares.
From here, I'm doing grouping. So, look, this all right here, if you're having any issues with this, start math lab, I need help with grouping. Okay? We okay with that? Okay, so this is our denominator, right? Okay, so now, I'm gonna ignore this for now, okay? Everyone just remember we have this as part of our answer. And I'm just gonna work on this integral. All right, so to save myself from having to write this again, I'm just gonna go, this is equal to x plus 1 times x minus 1 squared. So we have completely factored out the denominator. Now, you might ask yourself, like, could you have used that, right? Like, what if you didn't see that that was a difference of squares? Like, could you have used this? The answer is actually no, because for us to use partial fractions, we have to look at the factors. And these factors, we ask ourselves, are they linear, right? If they're linear, are they distinct? Or do we have repeated ones? And then if we ever see quadratics, they have to be irreducible. And this quadratic is reducible. So you have to see that factoring in there. All right, now we come back over here, we say, all right, I'm going to have a linear factor, right? And a repeated linear factor, right? Distinct linear factors, one of them's just this one, the other one's repeated. So I'm ready to start the partial fraction decomposition. So like most Cal 2 classes, like this next step, like what I'm doing here is not even shown. It's just, now you do partial fraction decomposition. And they just move to the next line on the integral. Like they just write out what the decomposition is. Okay? I'm showing you all the steps because, right, I mean that's the part that trips people up. So I think it's important to go through it. 4x over, I don't mean like every Cal 2 class. I just know the Cal 2 class I took, they didn't remind me of what partial fraction decomposition was. So, but that's the weakness that a lot of students have, is they just don't remember it, so they get here and they feel like they're lost. This is it. Okay, constant over the first linear factor, constant over the second one, then remember the powers come up. And now we clear the fractions. So we multiply the left side by this. What would be left over here on the left? 4x. Okay, now I'm going to pull some sticks because we had some trouble last time through here on this one. How about max?
Okay, so your first A term would be A times x minus, x minus 1.
X minus
And then
1.
times x minus 1 squared.
Wait a minute. What are we multiplying both sides? We're multiplying both sides by this, right? By that?
Okay, yeah, so just do that.
Squared. So what cancels? The only thing that canceled is the x plus 1. So you're left with that. You want to keep going, Max?
Sure.
Okay, so on this one,
That one's going to be b, and then x plus 1.
yeah,
And then x minus 1 squared.
there you go. Squared or no?
Just, yeah, no square.
Just one factor of it, right? So one of the factors of x minus 1 there, and then you want to do the last one, Max?
Sure, it's just going to be c x minus 1.
X plus 1. Okay, good. So that's what happens when we multiply by the LCD. All right. Chris? Christopher?
Me?
Yeah. it's you. What do we do now?
We gotta make sure, we gotta get rid of B and C.
Yeah, so you want to try the short way? Let's try the short way. So if we try the short way, you're going to go after A first. So you got to be able to kill both of these.
So X equals 0.
X 0 won't kill this. If X is 0, you just get C times 1.
If you want to get rid of C, you have to.
Negative 1? Is that what you said?
I think it's 1.
Or 1?
Just 1.
Well, he's trying to preserve A. He's trying to preserve A, so if he's going to preserve A, he can't let X be 1 or it's gone. So he's saying
Negative 1.
negative 1, right? Okay, so X is negative 1. Okay, if X is negative 1, Chris, what's the left side? Negative 4 equals, now you have to do negative 1 in here, right? So negative 1 minus 1, negative 2 squared is 4, so 4A. And then here, this should be 0, that should be 0, and we should get A here, right? A is what?
1.
Negative 1, right? All right. Okay. Tatum? Do you want to go after B? Okay, so hold on, let me try something here. Do you want me to go after B or no?
No, oh, never mind. Let's go for C.
Why not B?
The separate telling me no.
I know, but I need you to see why though,
Okay.
okay? Because I'm sure,
It'd be 1B left.
if you were gonna try and preserve this, right?
Yes.
If you were gonna preserve this, then you would have to kill this off for sure, right?
Yes.
What's the only way you can kill that off? If
1.
x is 1, right?
Yes.
But what happens to this when x is 1? It also goes away, right? And over here, to kill this one off, you'd have to let x be -1, but that kills that off. See, this contains both factors from here and here. So there's no way you're ever gonna get b. You all agree with that? Like, not this short way. Okay, so go after c then. Is there a way to preserve c and kill those? So what factor is not here that's in both of those?
The X minus 1.
That's right, so all you have to do is make that go to 0, so let x be 1,
Yes.
right? So I'm going to let x be 1. Now if x is 1, we go through the whole thing again, right? So Taylor, what would we have here? 4 times, right? So 4 equals gone, right? Gone,
Yes. And then 2C.
2c, and therefore c is.
Or no, actually, 2. It's 2.
Okay, we have A, we have C. We just don't have B, and there's no way to use the short way to get it. Right? So, I mean, do we then have to go to the long way now? I mean, there's actually several different paths you could take at this point. We know what A is, and we know what C is, right? So we could just replace A with -1, and we could replace C with 2, and kind of expand everything out. Or we could just leave A, B, and C the way they are and come up with a system of equations that will have A, B, and C in them, in the system. But we know what A and C are already. So we have 2 of the answers of the 3. I guess the point is, the shortcut helped, but it didn't get us all the way there. Do you all agree? Okay, what do you want me to do? Do you want me to just expand this all out, leave A, B, and C the same, and come up with a system of equations, and then replace it? Or do you want me to replace them now and then expand?
You're already 3/4 of the way done.
Well, I haven't started expanding yet, though.
But I mean, it could be
Leave it as,
not.
you know what, I'm going to leave it as A, B, C. Here's why. Because in a problem, there are problems out there where you can't isolate any of them. Like you can never kill off one of them. Or, you know what I'm saying? Like you can't ever figure out what A is. So I'm going to keep this in mind that A is -1 and C is 2. Okay, I'm going to keep that in mind, but I'm going to act as if I just did this with the long method, right? So here's the long method. I would have taken this, I would have had 4x equals, I would have squared this. That squared would be x squared minus 2x plus 1, right? X squared minus 2x plus 1. But then I would have distributed an a through. So I'd have ax squared minus 2ax plus a. Everyone understand what I did there? Okay, here, what if I multiply those two together? That would be x squared minus 1, difference of squares, right? And then I would have distributed a b through. So this should be bx squared minus b. And then the last one's actually not that bad, it's just cx plus c. Okay, so that's me expanding everything. Now what I do is I collect my like terms together. So watch what I do here. Alright, so I put my x squared terms together. These two, right, are my only x squared terms. And then I pulled the x squared out, and that left me with this. And then I put my x terms together, which is, that's an x term, and that's an x term. Put those together, and then pulled out the x. And then I put my constants together, like that. Okay, do y'all remember why I did this? Why I wrote it like this with factoring these things out? What do you do at this point?
So you look at the numerator from the original and evaluate what factors you actually have. If you have an x squared in the numerator, if you have an x, you have a constant. And then you need to,
Numerator?
the numerator from that, like right there.
Oh, yeah, right here, this.
Yeah.
Okay,
So,
yeah.
like,
Yeah, so
you have
this
zero
side of
x
the
squared.
equation has to match that side, right?
You'd have like 0x squared.
I have no x squareds,
Right, so you
right?
have
So
to
that
say
means a plus b has to be
0.
0, okay? And then do I have any x's? Well, yeah, I have 4 of them, right? So negative 2a plus c must be 4. And then do we have any constants by themselves on this side? No, just 0, right, you could say? So I know that a minus b plus c must be 0. Okay, so as a system of equations, it looks like this. We have a plus b, right, equals 0. And then we have negative 2a plus c equals 4. And then we have a minus b plus c equals 0. So that's, if we would have done the long method, that's where we would have been, right? And then we would have had to have solved that system of equations. 3 equations, 3 unknowns, right? But we actually know what a and c are, don't we? So if I know what a is, I can get this first equation pretty quick, right? I can get b. It's right from here. It's from that first one right there. I know that a is negative 1, so plus b, that has to be 0, which means b is what? 1. Okay, and we're done. Now we know a, b, and c. Yes?
I have a question.
Yes.
On a test, if we can figure out, like from the beginning that, you know, a plus b equals 0, we only need b, do you need us to write all this other, the rest of the system of equations?
On the test, I'm gonna prefer that you are using your calculator to solve a system of equations. We just haven't gotten there yet. Like at the end of the day, when it comes to solving systems of equations, everyone in here should know how to use their calculator to do it. I'm gonna show everyone to make sure everyone knows how to do it. Now you have to have a graphing calculator. Most of the time you have to have a graphing calculator. Some of the other ones can do it, but we'll talk about that. Does that answer your question? Like on the test, if you were to got to there and said, that's all I need and I'm gonna stop, that would be fine.
Okay.
That'd be fine. All right. Yeah, what the hell are we doing? I forgot what we're doing. Okay, so here's where we are, right? We're doing this, we're trying to do this integral, now we know a, we know b, we know c. Yes? Okay, so let's continue the problem now. So back to our answer. And I'm going back to where we had our answer going, right? Our answer is 1/2 x squared plus x, was that it?
Yes.
Okay, and then it was plus, now the integral, and then we took that thing right there, and we just broke it up into its partial fraction decomposition. What's a? A was 2 or what? Negative 1, right? A was negative 1, so we have negative 1 over x plus 1. And then we have plus, what was b? B was 1, so 1 over x minus 1. And then what was c? 2, so plus 2 over x minus 1 squared. Okay, all of that dx. There we go. dx. We're integrating.
Oh, right.
All right, so now 1/2 x squared plus x. All right, for this one, the negative can come out, right? And then we have 1 over x plus 1. The antiderivative of that's just natural log. So minus natural log of x plus 1. All right, this one right here. Yeah, is that pretty straightforward or no? Natural log x minus 1. Okay, this next one, you have to be a little careful because that's not natural log anymore, because it's squared. Yeah, so, just a little basic u sub on that one. So we did that last class. I would pull the 2 out, I would have 1 over x minus 1 squared dx, do a little quick u sub, x minus 1, du is dx. So this really looks like 2, 1 over u squared du. We did this last class. This is the same as 2 integral of u to the negative 2 du, so anterior to that's negative 2u to the negative 1. Negative 2u to the negative 1. So this is going to become negative 2u to the negative 1 is really that to the negative 1, which is really 1 over x minus 1. Plus c. All right, that's the antiderivative. Yes, you can combine natural logs. You don't have to by any means, but you know the book might if you're looking at the answer in the back. And that good exercise, I guess. All right. So what do y'all think? Y'all enjoying this so far?
There you go. Finally, okay.
Yeah. How many more of these do we have? Okay, I only have 2 more to do. Two more, and then we're done with techniques of integration. So, statement class, please. Don't drop. Don't drop. Have a good one. I hope it goes well.
You make it sound like it's such a wonderful thing, and then like the very next thing is what? Series. Right after.
No, we don't get series right away.
Oh.
There's a little bit of
There's a
a
lot.
stay of execution. No. The material actually, I think, does get a little bit easier for a short period of time. It does, because it becomes very visual. And if you can handle the visualizations, the next couple of sections after this aren't so terrible, I guess. I can tell you this, the integration's not as bad. You'll have integrals that you're doing, but they won't be as bad as this stuff. Yeah. And don't get me wrong, series is not that it's like impossibly hard. It's just series is different. Like most people have not seen series. So how many of you have seen series? Right? How many of you had seen some integration before you got here in this class? Okay, maybe high school, some people take like BC AP calculus, BC calculus, so some people have seen integration, but series most people have never seen. All right, yeah, what are we doing here?
Back to the bottom.
Back to the bottom, right? Okay, we don't need long division, right? Okay, so when we factor that denominator, 2x squared minus x plus 4 over, all we can do is factor an x out, right? That's it. X, and then we're left with x squared plus 4. And you cannot break down x squared plus 4, right? That is irreducible. It's an irreducible quadratic. Agree? Okay. So we know we're going to do partial fractions now. And the idea here is that if we're looking at this expression, like this, I have one distinct linear factor, right, x, and then I have a single irreducible quadratic factor. So for a linear factor, I put a constant over the linear factor. And then for the irreducible quadratic factor, what do I put on top? Bx plus c, a linear expression. Bx plus c, and then over my x squared plus 4. Okay. And now we clear fractions again, right? Clear fractions. So left side becomes 2x squared minus x plus 4. Okay, when you multiply through over here, you're going to have a, and what's with the a? X squared plus 4, right? And then plus, now be careful on this one, because remember I multiplied through by x times x squared plus 4, right?
X.
So I'm just gonna have an x left when these cancel, but I still have that too, right? So I have bx plus c times dx, and I'll distribute it through. Let me go ahead, well, yeah, I'll just, well,
Doesn't-
it looks a little different than the stuff before, right? Does it look a little different? Yes?
I'm confused on where the BX plus C came from.
That's what you have to do anytime, you know how when we've had like a linear factor down here, we put a over it? Anytime it's quadratic and we can't factor it, we have to put a linear expression over it. So think of it like like in terms of a degree. If you have like, you have a constant, like in the order of things, you have constants, linear, quadratic, cubic, right, degrees. So if you have a linear, on top of it you put one order less than it, which would be constant. If you have quadratic, then on top of it you put one order less than it, which would be linear. If we had a cubic down here, then we'd want to put a quadratic on top of it.
So
We don't go into that in this class.
Like
if you have a cubic on the bottom.
BX squared.
What?
BX squared plus C, or
If this was, if down here we had an irreducible cubic function, or cubic expression, you would put something like bx squared plus cx plus d.
Oh.
But that's beyond the scope of this class. But it generalizes that way. Okay. Okay, what were you saying?
Can we solve for a now before you distribute by making x 0?
You can make it x0 and get a. Do y'all agree?
I agree.
Okay, we can do that.
Distribute after.
All right, no problem with that. Let's do it. Let x be 0. And if we let x be 0, then we get 4 here equals, and then over here we get 4a, right? And this stuff's gone. So a is 1. Good for us. Well, we're one of, we've got a third of them, right? We need 2 more. So how are we going to get these?
The long way.
I'm sorry?
You're gonna use the long way, right?
I think we're going to have to. And the reason why is because you can't kill A, right? You can only kill A if what?
If it wasn't squared, because you need a negative.
Yeah, you would basically start to have to bring imaginary numbers in to make this happen. We're not allowed to play with
Can you use
that.
a system of equations and like say set a plus b equals 2 and then
No.
like multiply all that crap out?
Yes, that's what I'm doing. Multiply, that's what we're going to do.
Okay.
But the short won't work anymore because there's no way I can kill this, all right? So I'm going to go ahead and just expand out. This is going to go here, here, the x goes through here, here. So I've got 2x squared minus x plus 4 equals ax squared plus 4a plus bx squared plus cx. Collecting like terms together. A plus b
Yep.
is in front of x squared. And I only have one thing in front of x, that's c. And I only have one number by itself, which is 4a. It's actually going to work out real nice.
Negative C equals
one.
negative 1, right?
Negative 1.
c is what?
Oh, sorry. Never mind.
Well, like when you said it's
Alright, sorry, I'm fine.
Okay, so
Yeah.
you're ahead of me.
Yeah.
Okay, you're ahead of me. That's our expansion. And now we just match the coefficients. So I know a plus b has to be 2, right? I know that c has to match the coefficient there, so it has to be what, negative 1? And then I know 4a has to be 4. So I'm just going to write the system down here. This is a plus b must be 2. And then the next one is that c must be negative 1. And the last one is that 4a must equal 4. And that's my system of equations. But it's a very easy system of equations to get, to work with, right? We know what c is. We know what a is. Right? So to get b, yeah, plug in. So we know a is 1. We know c is negative 1. And to get b, we just plug in 1 into there, so b is 1, right? Sorry? All right, that's it, yes? I mean, that's, the partial fraction's done. Now we rewrite the integral. So this integral right here, right? This integral right here now becomes the integral of a over x, so 1 over x, plus bx plus c. B is
Just X.
B is 1, so just x and then
Plus
plus c, so minus 1 over x squared plus 4 dx. Man. Are you happy to see the first part? Yes? Okay, I'm happy to see it. So that's going to be natural log. Now what about the second piece of this integral? What do we have here? Linear over irreducible quadratic, right? Linear over reducible quadratic. Linear over reducible quadratic. Linear over reducible quadratic. Well, we did a few of those, didn't we? Do you remember the way I did it? Complete the square is what we do if this is a constant on top. No?
No, you did use sub, but you added, you made it.
That's
into
right.
the-
This is the one where I
Add the
did a
special
little
one.
magic, right? So this is going to be natural log x. Okay, done with that one. Plus this integral x minus 1 over x squared plus 4 dx. So this is the one where I said, okay, look, we're gonna say u is going to be equal to x squared plus 4, right? Du, what would we really like it to be?
X minus 1.
Well, that's what we have, but, yes, okay, I take that back. We have 2x dx, right? We'd really like it to be that, yes? So, or we'd really like for this to be this, is the way I should say that. Right, so how can I make that turn into this? Multiply by 1, so I'm going to multiply out here, 2 over 2, so I'm going to have a 1/2 here, and the 2 I'm going to pass through is going to make that 2 and that 2. Yes? Does anyone see what my next step is? Are you saying yeah, or what am I going to do?
Like, subtract 1 and add 1.
I could subtract, what would I subtract and add though? So I need it to be 2x, right? I have 2x minus 2.
You could just break it in half, right?
Yeah, just right now, just split it. Because you need it to be 2x, right, dx? If I split this into two integrals, one of them would be this. Okay, that's just me looking at that part of it. Yes? And then the other one, if I put the other one next to it, I have minus 1/2 and then 2 over x squared plus 4 dx. So this one, how would we integrate this one now? This is just basic u sub, right? That's the u, du, it's all right here, it's all perfect, right? How do you do this one? X squared minus 4. We take the 2 out, right? You can take that 2 out. You have 1 over x squared plus 4.
Yeah, there's
Right.
x for you. No, never mind.
Formula 17.
Formula 17.
Oh, man.
Was.
Right?
So rude.
It doesn't, Calci doesn't care about your feelings.
Yeah.
At all.
Yeah.
At all. I mean, I do.
No, you don't. Don't lie.
I do. I
Liars go to
care.
Congress,
I
don't
care.
lie.
Plus, let's see, 1/2. Okay, so this integral right here, this is going to be u on the bottom, du on the top, right?
Yeah.
So this is just going to be 1 over u, natural log. So Natural log of what though? Because our u is that, right? X squared plus 4. Okay, that takes care of that one. So we've got this done, this done. This one, we said the 2's going to come out, 2's out, and that's going to be our formula 17.
Wait, didn't the two come out of the other one? So you wouldn't have that half?
I did not, what, the 2 here?
Yeah.
I did not take it out because I wanted the top to be exactly
Okay.
du,
Okay.
right? All right, so here, minus, okay, what is a for us here? A is 2, right? Because that's x squared plus 4. So this is going to be 1/2 arctan of x over 2 plus c. Wow, okay.
My bad.
That's it. One more. One more, then you get to go enjoy your weekend with these.
Oh, the cow cactus guy.
Right.
The cactus
But the
guy.
messenger, only the messenger. Hold on a second.
That looks like.
Can we do this problem?
Yeah, I already did that one.
Do I not have to do this now? Oh, wait, hold on. Did I scroll the wrong way?
Yeah.
Yeah, I scrolled the wrong way.
I already read it.
Yeah, we need long division, because it is,
Equal.
yeah, because the numerator and denominator degrees are the same, right? Okay. Let's do it. Long division, that's what I'm being told, yes? We agree? Okay, all right, so we go long division here. I'm sorry. A little moment there. Did I ever press record?
Dude.
I can't tell.
Yeah, there's a red light on.
Is there a red light on?
Yeah.
On the camera? There's a light. Oh, I just couldn't see. Yeah, we're good. All right. What goes first here? 1, right? Multiply by 1. We get 1 times that. So 1 times everything. Just put it here. Minus 4x plus 3. Subtract or change signs. Minus, plus, minus. Add down. X minus 1. And we have to stop here, right? Can't go any further. So this is going to be plus x minus 1 over the divisor, 4x squared minus 4x plus 3. Okay, do you like it? I mean, not do you like it. Do you agree with it?
Because you don't care if you like it.
Yeah. Well, I care if you like it, but
Calculus.
calculus. Hey, check this out. Sometimes you can do this. Watch this. Watch this. Watch this. Just watch. Oh, wait, hold on. Okay. Do you agree with me that the numerator is actually that? Do you see, I rewrote this top one as 4x squared minus 4x plus 3 plus x minus 1. So if I put this together with this, I get minus 3x, and if I put this with this, I get plus 2. Do y'all see that?
Yep.
But do you see that these 3 over that, if I broke this up into 2 fractions, that over that and that over that, that's legal.